Is it started? Oh, okay, let me check again. Is it recording or not? Oh, yeah. Looks like it is. Okay, yeah. So today we'll be talking about one topic here, that is BGP services. Actually, yeah, I was thinking again, maybe the title is not services, because services is, yeah, to some extent we can say this is services like a transit or peering, but yeah, this is type of peering. This is how you connect to each other. Yeah, I was thinking to have to say the title here about BGP connectivity. The way you connect your BGP either is through IP transit or IP peering, which determine how much does it cost to connect to the internet. Okay, so today's topic is, as you can see here, we will be talking about the IP transit and IP peering. What's the difference between them? And yeah, my name is Achmad Mardiansyah. I'm from GLC Networks Indonesia. Okay, so agenda. These are our agenda. Yeah, so there will be introduction, review some stuff, which we assume you already know that. Okay, because this is not a very beginner topics. At least you must have some foundation before attending this webinar. Okay, so we will review some some topics about that. Okay, after that, talking about the IP services and then the type of connectivity like IP transit or peering. All right. Okay. Everything's good. Okay, let's get started. What is GLC? We are Garda Lintas Cakrawala. We are based in Bandung, and our our areas are training and IT consulting. We are doing MikroTik, Ubiquiti, Linux mostly. We are doing radios manager with the billing as well. And then we also do regular events like we are doing today, every week. My name is Achmad Mardiansyah. I'm based in Bandung. I'm a Linux user, MikroTik user, Cisco user, PHP user, whatever user. Because I'm doing here as a consultant, and as a consultant, we provide solutions, and then the solutions can be can be anything, not always related to networking, but as long as it can solve customers problem, and then they just be fine. Okay, so I also have LinkedIn account, and then I would like to connect with you guys if you don't mind. Just connect with me. Past experience in Malaysia, in Congo, in Africa, in Libya, in United Kingdom, in Bulgaria. I mean, mostly I do networking related and telco. And yeah, today we'll be talking about the BGP. For a webinar itself, if you want to become a presenter, you're very welcome. Just let us know, send us email, and then you're good to go. Okay, thank you very much for introduction. So I can see here many are coming from many places. Okay, so up to now we have 68 participants. Thank you. Wow, that's a lot. And so prerequisite, we'll be talking about how networking works, how internet works, and then yeah, we assume you already know how computer network is connected and then how it works. Okay, so let's review how internet works. So initially, it's yeah, we talk about when we talk about the computer network, like it or not, it's a bit of history. So it's initially a research project, and in the 70s or 80s, and then liberalizations. Now it's public utility and critical infrastructure, because many applications are rely on internet network. Okay, so before the internet, actually computer networking is not new. It's already exists, but many of them are proprietary. So IBM can only talk to IBM. DEC only able to talk with DEC. What else? Apple, yeah, Apple was there, right? In 1980s. Apple can talk to Apple only, yeah, which is not good. So how can we talk to each other? So that's why we need standard. So standard is simply is an agreement. It's like a language, a set of rules, okay, which allow interoperability. And then what we want is an open standard. Okay, as the open standard means it's a standard can be developed through open and accessible process. So it's open for everyone, freely accessible, implementable, usable. So all the specification is there, okay, and anyone can access. So that's kind of standard or protocol that we really want to do. And then we implement it, and then it becomes the internet standard. So if you see, internet standard is like here. So previously we don't, oops. So previously we don't have any standard here, and now between these vendors here and here, we have standard. And one standard that is majority adopted around the world is a TCP IP standard, the standard that is based on TCP and IP protocol. Okay, so based on these two protocols, we are using internet up to today. Okay, so as you can see, after we have standards, and then we can connect to each other, and then communication is very easy up to now. So why we use the internet? Because it's open, okay, free standard. We don't, I mean, you don't have to pay for the standards, right? You don't have to pay for TCP, right? What you pay is a monthly fee for the connection for the hardware, okay, and then usually it's lease, okay, or rent. But the internet itself is free, okay. It's open, it's lightweight, it's a global end-to-end. And then why is it possible to have at end-to-end? Because we can have a global IP address, which will be discussed later. And then it's neutral, okay? So internet is not belong to Apple or Google, or long time ago it was Microsoft or IBM or whatever, okay? So, yeah, so that's why we use the internet now, because it's very accessible for everyone. Next, when we talk about communications, we talk about layers. So each layer is responsible for one functions, like wires, exchange, local loop, and devices. So each layer is responsible for one function. Yeah, layers in communications can be depicted like this. So usually we have an infrastructure layer, okay? And yeah, this is like infrastructure. So this is a traditional one here, and then versus the internet. Okay, so previously we have infrastructures like a fixed line, dial-up, mobile, cables, and then we have a network where we have a voice. So this is telecom. This is we video long time ago, okay, in 1990s or 2000s. So we have a cable for cable modem, cable TV. They have their own cables, they have their own pole, okay. And then we have a telephone cable. It's another cable, and then we have what else cable? A data cables, yeah. So it's a different one. So okay, as you can see, all of them requires their own infrastructure, which is makes the cost higher, right? And then here's the applications. With the internet, we can just use a single specification of network, which is the internet. And then on top of that, we can send a voice, email, videos, many things, okay? And then the infrastructure itself can be many things, okay? We can use WiMAX, so 4G to 5G, 3G, cable, fiber optics, Ethernet, whatever. So by using this protocol, this internet protocol, as long as they all of them support IP protocol, and then everything should be easy, because that protocol, the IP protocol, is worldwide acceptable. Actually, there is no regulations, written regulation. It's not allowed. But when we talk about the technology, it depends on how wide does the technology are accepted by many people. Okay, and then as you can see, internet is very widely adopted by many organizations. So we know about the layers in communications, and then if we talk more about that, and then actually the model for the layers is referenced by OC. Okay, so OC, we have 7-layer OC model, started from application, presentation, session, transport layer, network, data link, and physical. So protocol, it's a set of rules of communications, and each protocol has its own, each layer has its own protocol. For example, on layer 4 here, we have a protocol for TCP, UDP, SCTP, DCCP, SPX, and so on and so forth. Okay, so that's how communication works. And then the way we communicate is we talk on all layers at the same time. So data from one layer needs to be passed, needs to be added with the information by other layers. And then this process is called encapsulation. Okay. So the encapsulation will be like this diagram. Okay. So the data from upper layers, like when you say something on WhatsApp, and then the WhatsApp will add TCP header, become like this, and then we'll add a new header for IP. Okay, IP becomes this one, and then add a new header for layer 2, and then it becomes frame. So we have a special call name for, we call it PDU. So after the data is added, and that it will become a PDU, protocol data unit. And then on layer 4, we call it segment if it's used TCP, or the datagram if it is used UDP. And then after that, we call it packets, and then the last one is frame. Okay, so that's the encapsulation process. And then the internet addressing. So as I said previously, when we, internet is a global communication. Why? Because we are using global address. So an address where is very unique in the world. Okay, so only you is able to use that address only. Okay, it's called internet addressing. So that is to avoid yeah, if address is not unique, and then how can you communicate, right? So if you send a package through a post office or through courier like FedEx or UPS, if the addressing is same, and then how can the package arrive to the destinations, right? So that's why we need an addressing. So the address itself, the specification of addressing is based on RFC 791. Okay, so that's the specification of IP. You can just Google it. The address has to be unique, so we need an international body that regulates the IP addressing, and then it's called IANA, Internet Assigned Number Authority. You can just Google it. There is a website for that. So IANA has very wide authority. One of them is regulating the IP address allocation. Okay, because it's very big, IANA delegates to RIR here, Regional Internet Registry, and then IIR delegates to country. Okay, we have 1, 2, 3, 4, 5. Okay, we have RIR for Asia Pacific. This one here. Okay, it's called APNIC. For Africa, it's called AFRINIC. Okay. For Europe, here it's called Tribe NCC. Okay, so for ARIN, North America, yeah, I mean only 2 countries, right? America and Canada, it's called ARIN. And then for Latin America, it's called LACNIC. Okay, so if you want to connect, so every organization in that is participate in internet must contact one of these RIR, Regional Internet Registry, so that they can connect to the internet. Okay, so if you are an organization and then you want to connect to the internet, you must have IP address block and then autonomous system number to connect to the internet. And then you will get these 2 numbers from RIR. I'm from Indonesia, so I will contact IPNIC. IPNIC is located in Brisbane. Brisbane is here. Okay. Yeah, it's like I think 1 hour flights from Sydney. Yeah, yeah. Yeah, if you don't want to go to Brisbane, and then I'm in Indonesia, so this is Indonesia. So I just contact the local authority that manage the IP address. Okay, so I contact them. I need an IP address, and then I want to have an autonomous system. And then they will say, okay, you can get this IP address block. And then the way you manage the IP address block is by renting the IP address. Okay, so IP address is not an ownership, but the way you use it is by renting the IP address. So as long as you pay the IP address, and then you can use that IP address block. Otherwise, you have to release that IP address. Okay, so that's how you use an IP address. Okay, so far the concept is clear, hopefully. Okay, guys, if you have any questions, and then just type the question in the chat box, and then I will discuss about the questions later. So this is how autonomous system looks like. Sometimes we call it AS, AS number. So it's the number that identify your organization. Okay, so its AS number is a collection of networks that have same routing policy, like a same. I want to block this one. It's like a routing policy. Okay. Usually they use a single routing protocol, single ownership usually. Okay, but there is a possibility that my organization GLC network has 2 AS. It is possible, yes. Yeah, so that's why the definition of AS is a collection of networks that have same routing policy. Okay, so identified by 32-bit. So previously 16, now it's 32-bit. Okay, so that's how AS looks like. Now let's talk about the topology, how the computer network looks like, either physically or logically. So this is the common network devices. We have hubs, switches, routers, and firewalls. Okay, so I assume you only know on which layer they're operating. Hub is layer 1, switch layer 2, layer 3, and then firewall can be on any layers. And then at least you know what's the difference between router and routing. Okay, router is the device, routing is the process. Okay, and then what they're processing is they're processing layer 3 informations like here. Layer 3 information is IP header, either it's IPv4 header or IPv6 header. Okay, so these are the header of the protocols. I mean, if you can, if you do the protocol analysis like K12, K15, or Wireshark, you can see the header in more details. Okay, so this is typical connection. Okay, I think I missed this one. Oh yeah, so after we have a routing and router, so usually we set up the devices, these devices into a connection of a series of physical connection. So yeah, that's why even though it's wireless, it has to be connected in some way. Okay, so as you can see, we need to have a physical connection. So internet is actually is a series of physical connection. Okay, if you're not connected, then how can you connect to the internet, right? So for example, this is router. Okay, let me take another color. Oops. Yeah, so we have a router here, another router here, and then they're physically connected through a switch here using this cable, this cable, this cable, and then connect to, for example, an access point here. And then you guys, people connect through wireless with Wi-Fi. And then this router connects you to a switch and then connected wiredly to other device using cables. Yeah. And then they connect to the internet with the kind of connectivity like this. So actually, internet is a physical connection. Okay, a series of physical connection, and with these physical connections, we can set up the connectivity in a logical way. So on logical way, we are not talking about the physical connectivity anymore, but more on IP addressing. So it means that we are talking on the layer 3. So instead of, okay, where's the switch? We start talking about the layer 3 connectivity. Okay, so we're talking about this segmentation of IP addressing. So this segment connect to this segment connected to that segment. So that segment that I mentioned previously was this things like this. So a segment of a network. Okay, we call it prefix, is prefix. So in a logical connectivity, logical topology, we are talking about subnet. So this subnet connect to that subnet, connected to that subnet. So if there is a connectivity between subnet, and then there must be a router in between. Okay. Any questions so far? Looks like everyone is okay. So, so we already know that, okay, oh, actually the computer network is based on the physical connectivity. Yes, yes, very true. So what about the internet? Well, the internet is same. So because internet is is higher, is bigger scale of your current network, a LAN network, or office network. Is a similar way, similar but in the bigger scale. So network is just like this. So one network means one AS number. So this is how they connect. Okay, so here it means that it's a physical connectivity here. Okay, physical, 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 and then inside them is another physical. Okay, so as you can see, one big network can be put like one bubble like this. Okay, which represent one network, and then one network can connect to other networks. So that's how internet works. Okay, and then one network is, for example, has its own routing table. For example, this prefix belong to this prefix belong to that, this prefix belongs to this network, this prefix belong to that network. Okay, so every network must have their own IP address block. And then what about my ISP? Well, so this is your ISP, and this is your house, your place. Okay, so this is how they connect. Okay, so this is your ISP. Okay, so this URP is this big, and then one dot over here is your place. Okay, so that's how they connect. That's how internet is connected to each other. So you have one connectivity connect to other connectivity, and then that's it. That's how you connect. Okay, as simple as that. And then how do they connect? Well, it's up to them. They can roll out a fiber optic cable that lies on 50 kilometers, 10 kilometers, 5 kilometers, whatever. Even thousands or hundreds of kilometers, like from Japan to America, from Japan to Hong Kong, for example, from Singapore to Jakarta. Yeah. So again, internet is a bunch of physical connection. Yeah, I mean, if you want to have a connectivity, you must have a physical connectivity, right? Yeah, so if we look closer, this is how it looks like. Okay, so this is your house. Okay, so this is your house. Oops. Okay, so this is one dot here. This is your house. And then you connect to a maybe splitter if you're using GPON. And then here's the concentrator, okay, where you are authenticated. And then here's the router, and then another routers, and then they connect to other ISP over here. Okay, so this is you. Okay, you connect to the access network either through GPON, wireless LAN, fiber optic, GSM, whatever. Okay, and then there will be an access routers where you get IP address from here. CCU, and then you connect to the clouds of routers that belongs to an ISP. So this is an ISP looks like. Okay. So the things that I draw here, okay, is one ISP, and then this one ISP connect to other ISP. Actually, not always ISP or organization. I would say AS. Yeah, because this ISP, because it's big, so I'm ISP, this is ISP. My ISP can connect to Google, for example. This is Google. And then this is Facebook, okay, where you post your pictures, Instagram and WhatsApp, and then many things over there. Okay, so that's is how you connect to the internet physically. Oops. Oh, okay, I have a question. There is a question here. What kind of device of router capable to handle huge customer? So that question needs to be addressed to the vendor, like Huawei, ZTE, Cisco, Juniper, and MikroTik, Ubiquiti. Yeah, they have the answer. If you want a cheaper one, then you can use MikroTik. Yeah, the highest type of MikroTik is, I think, CCR's 72. Yeah, I forgot the name. The last one is 72. That has 72 cores. But if you want to get higher, then better if you use x86 platform, where you can upgrade the physical connectivity up to unlimited. Okay, you can put 100 gig interface, 200 gig interface, whatever. Okay. Yeah, so as long as you have money. Okay, so moving on. Yeah, so as you can see, oops, yeah. So this, we already talked about the physical connectivity, how you connect to the internet. Okay, so from your place connected to an access network. For example, in my house here, I am connected to a provider, and then that provider is using GPON technology. So they connect an ONU in my place to their OLT in their like a data center. Okay, so from my place to their OLT, the range could be 1 kilometer, 500 meters, whatever. Okay, so that can be short, that can be long. So depends on the on the place. Okay, so from the OLT, they must connect to the local access router, and then from that router, they connect to the other routers, and then to their border routers, and then connect to the other AS number. So that's how it looks like. So yeah, that's the physical connectivity. So now let's talk about, okay, so what about the protocol that's so, okay, so we already have this physical connectivity. What about because one aspect for communication is on IP is routing, right? So we already know routers, and then what about routing? So routing is handled by the routing protocol that is run on the router itself. So one protocol that is widely used for handling internet type connectivity is BGP, a border gateway protocol. So this is the one and the only protocol up to now which can handle the internet size routing table, because right now, last time I checked, the full route for BGP for all BGP around the world is 800,000 and 870,000 routing prefix. Okay, so as you can see, there are 870,000 networks, okay, a subnet around the world up to now. Okay, so why BGP is used? Because it's path factor protocol, incremental updates, blah, 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 blah. We will discuss the BGP features and how to connect to the BGP in BGP training. Not today, not tonight, not this time. Okay. Yeah, it supports VLSM. It's variable length subnet mask. It's a technique where where you split the IP address. IP address has IPv4, for example, has 32 bits, and then you split which bit is for network which bit is for host, okay, by using the slash. Okay, so previously we use VLSM, but not explicit. That's why we still use class A, class B, class C. Now we don't use class A, class B, class C. It's already over, guys. So please, if you are writing in internet books, please do not say class A, class B, class C, guys, please, because we don't use it anymore. Okay, what we are using is slash because we already use the VLSM. Okay. So this is the RFC, was done in 1995, and every routers already adopted, and then they update the firmware since 1995. So since 1995, the term for class A, class B, class C is not valid anymore. Okay. What is CIDR? CIDR, because we already use VLSM. So that's why in routing, we need to be aware of that VLSM. So that's why we use the classless interdomain routing. So CIDR. The RFC is 1915. Okay, so this is the CIDR. So with CIDR, every routers like this is one example of the router. Okay, so they're using things like /24, /13, /17, /19. So as you can see, the ability or skill for subnetting is very crucial if you want to be a network engineer. Okay, so you are bullshit. You are not a very big bullshit of network engineer if you don't know how to do a network subnetting. Okay, a very big bullshit. Okay, so networks subnetting skill is a must-have skill if you want to be a network engineer, because as you can see, the subnet is not always 255 255 3 times. No. Okay, as you can see, we can, I mean, it's /19 can be /18. So it's not always 255 3 times and then 0. No. Okay. Oh, okay. I have a question here from Kensane Kobane. BGP same as NAT, but on larger scale? No, it's not. BGP is a routing protocol, and then that routing protocol can handle lots of prefix. And then up to now, the total prefix for full route from BGP is 870,000 something. I just checked up 1 hour ago. Okay. So this is path vector protocol. For example, your BGP router received this prefix, okay, and then you want to connect to that, and then you will set up a routing tables. Okay, so this is your target, okay, where you want to go, and then this is your gateway, okay, and then here's the gateway status here, and then in BGP there is a parameter called AS path. So BGP is not only talking about the, like when you do trace route. So, okay, so this IP address, this IP address, this router IP address. So what you're doing with the trace route is you're checking the path from source to the destination based on how many hops it happens on of a router. Yeah, so it's a series how many routers between source and destination. That's that's what you are looking for when you are doing trace route. Okay, but here BGP doesn't care about how many hops. They are care about how many AS path from source to destination. So for my router here, as you can see, so my, yeah, so so the destination address is belong to this, okay, and then the first AS is this. So if I want to go to this network, and then the first AS number that I'm going through is this AS number 23947. Okay. Yeah, so this is a path vector protocol. So when we talk about BGP, so this is router. So we just talk about, okay, we have a AS number. How many routers in AS number? Can be many, but we on BGP, we will see an AS number as just one dot. How many routers inside? Whatever, I don't care. Okay, so we have a AS number, AS number, AS number. So when we talk about BGP, we're not talking about how many hops, doesn't matter. We're just focusing on how many hops, how many AS number from source, for example, from A, for example, from A to B here. Okay, so coming from here, arriving from here, for example. Okay. So this is BGP connectivity, aka peering. So as you can see, if you want to connect, so this is your AS number, and then there will be a router that connects to other AS, and then that router is called border router. So how the border router looks like? Well, just like a normal router. So it's called border router because it connects to other AS number. That's it. That is very simple definition of border router. Yeah, I have a student, and he really confused about how border routers look like. It's just a normal router. If you put the router B here inside, and then it will not become a border router anymore. Okay, so border router is just a router that connects to other AS. That's it. Finish. Okay, do not make yourself difficult. So as you can see, AS102 only have one border routers, okay, but it connects to the two AS, AS101 and 100. Okay, so this is how the peering looks like in BGP. This is a BGP process. So as you can see, if you are doing peering with BGP, this is your router, okay. Look, guys, most of the slides here is not from me. I just take it from APNIC. Yeah, I have several friends in APNIC, so I just asked their permission to copy. So this is another router. So this is your router over here, and then you do BGP peering. Okay, so they will send you a prefix, and then they will give you, and then you will give them your own prefix. Okay, so this is the process. Okay, here's BGP in. Okay, depends on the filter that you put on BGP in. Some prefix can be discarded, some prefix can be accepted. Okay, and it's develop a BGP routing tables, and then you do you use that tables to develop to generate the forwarding table. So the things that you use for forwarding the packets is the forwarding tables. So if everything is okay, and then you will give them back the BGP out. So that this will be your outgoing filter. Okay, so this is your incoming filter. This is your outgoing filter. Okay, and then your peer will receive prefix from you. Oh, okay. I have a question here. BGP will choose routing based on number AS has to pass or based on time response. So there is an algorithm for BGP, how they connect, how they decide the prefix, because because for example here AS 100. Okay, so this is AS 100. This AS 100 connects to three AS or two AS. Okay, two AS 101, two AS 102, for example. So let's say I want to go to 8888. Okay, so this is my destination and this is my source. Okay, so there is a computer here with IP address, and then I want to go to 8888. So I can go through AS 101 or I can go through AS 102. Okay, so which peering should I choose? So there is an algorithm here which calculate to which peer should I forward this destination. Okay, so there's an algorithm for that. So not based on time response. No. Okay, let's move on. Yeah, so BGP has two types. We have a eBGP, external BGP, on iBGP. External BGP is between AS, internal BGP, internal AS. BGP, yeah, as you can see, BGP can be used internal as well. So this is how it looks like. Okay, so all of them are used BGP. Okay, but between AS, we use external BGP. Okay, inside AS, we call it internal BGP. And then the way we use internal BGP is we combine them with IGP, okay, interior gateway protocol. IGP can be what's the Cisco routing protocol? IEGRP, yeah, I forgot the name. EIGRP, I forgot the name. Or you can use OSPF, or you can use RIP. It's up to you, man. Okay. Yeah, so that's IGP. Okay, so please do not confuse. Okay, we have IGP, we have BGP, and then BGP we split into external BGP and internal BGP. Okay, so I can see some voice here, so please I will mute your voice. Okay, so it will not interfere with my own voice. Right, so let's move on. This is an example of external BGP. So actually, the difference between external and internal BGP is when you do the peering. So if the peering, if your peering partner is different AS than you, of course it must be an external BGP. If the AS is similar, and then it must be internal BGP. Okay, so external BGP usually directly connected, should be directly connected. Otherwise, how can you do that? Okay, there is an indirect BGP, yes. For example, when you do peering with Kimru, but you must have a direct BGP for that. Okay, and then this is the internal BGP, internal AS. Not required to be directly connected. So IGP will take out the inter BGP speaker. So this is gonna be complicated. It looks like complicated. So as I said, okay, when you run iBGP, you need help from IGP. Okay, let's say OSPF. Okay, so you run OSPF over here, here, and here. Okay, you run OSPF, and then on top of that, you need the help from OSPF. Okay, please do peering between me and my partner here, my router partner for internal BGP. Okay, so iBGP must be fully meshed. So A has to connect to B, A has to connect to C, A has to connect to D. D also same. Every router has to connect to each other. Yeah, that's the requirement for iBGP. Well, Oh, so that means there will be lots of lots of connectivity, lots of peering. So because so let's say I have five. I have five internal routers, and then I do IBGP. So I will do peering to all of them. Yes. Yeah. So you do peering like that. Here, here. So how many peerings in total? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So 10. Wow. That's a lot. What happened if I have 100 routers? So that's a lot. So I have to, so one router needs to connect to the 99 routers. Yeah, so that's why to avoid mesh peering, you can do AS confederation or route reflector. Okay. Oh, I have a question here. How to calculate memory size for each prefix BGP? Let's say I have 3 BGP peering and then for route at 100,000 route, how sizing memory. So ask your vendor. Usually in MikroTik router OS version 6, like what we are doing, the full route requires 400 MB memory. Okay, so if you have 2 full routes times 2, okay. If you use CCR and then you still have lots of memory, so that's enough. But the processing for BGP on MikroTik router OS is still single core. Okay, so only one core is used for BGP things. So that's why if you're still using MikroTik version 6, better if you use x86 platform because the clock is faster. But in version 7, which is still in beta, I don't know when they will release in stable version. There, the total requirement for one full route is less than that. Maybe one full route can 25% or 50%. So it's much lower than version 6. And then in version 7, the BGP. So because you know what BGP thinks is one many people love MikroTik because it's very affordable, lots of features, right. uh, but one fun thing that many people complain is about BGP because BGP in version 6 is still using single core. So it doesn't matter if you are using CCR 72, 1072, right? You have 72 core, but only one core is used for BGP. So that's why it takes several minutes to do the full routes. Yeah, full routes, several minutes, like 5 minutes. So it's slow. Also, the routing routing filter also slow. Why? Because yeah, that's single processing, single call processing. Now they have version 7, and then everyone is happy, but not yet happy because it's still on beta version. Okay, let's move on. Now let's talk about the connectivity itself. So as you can see, the peering types is depends. Okay, so with BGP you must have a peering. Okay, so between AS. Okay, so you must have a peering, and then the type of peering can be a transit or peering. So what's the difference between peer and this peering? So it depends on the situation where you are, where your ISP is located. Okay, so transit means the service provider the ISP. So if you say service provider is ISP, or service provided, I mean, yeah, service provided by the ISP. So it means that the ISP, okay? So this is ISP, and then the ISP connect to other ISP, right? Right. So this is they connect to each other, ISP, and then this is you. Okay, so you want to connect to, so this is the internet, right? Then you want to connect, and then it's called transit. Why? Because your traffic will be transit on the ISP, and then the ISP will charge you based on because you want to, because you use connectivity to them. Okay, so that's IP transit. So IndiHome or BizNet or MNC Play or Telstra or Exetel, what they do is just transit. Okay, so if you connect to the internet, it means you just transit. Okay, so you have to pay for them, right? So that's called transit. What happens if I have my own AS number here and I have my own public IP? Okay, you have your own ISN, you have your own public IP, and then how you connect to the internet? Okay, through your ISP. Okay, and then pay money for me. It's called transit. So that's how transit looks like. Okay, transit is pay, is commercial for money, but peering is not. But to do peering, you have to have a special place for peering. So this is IP peering example. I'm sure everyone knows where the place is. It's very famous in Indonesia, especially in Jakarta. So if you are a network engineer doing the BGP, you know this place, right? Okay, this one. Okay, we have a snooker table over here. And then we have interconnectivity racks on there. So one ISP connect to other ISP in this place. So we call this IP peering. Do you have to pay? Yes, but all are equal. So this is one ISP. This is a building, and then all ISP, all AS number connect to them. Okay. So what are inside the AS number? So I'm here not talking about the ISP. I'm talking here about the AS number now. So peering is between AS number, and then that AS number can be ISP, can be not ISP. Okay, for example, Facebook. Is Facebook ISP? No, it's not. But Facebook has IP address? Yes. Facebook has its own AS number? Yes. Facebook has their own IP address block? Yes. And then they will do connectivity here. Okay, so why they put their server here in ISP? Because that's where the many organizations connect. Okay, so if they put their own server in whatever, and then the connectivity from customer is gonna be difficult over there. Okay, so that's how it connects in IP peering. Okay, so IP peering usually happens in a place where all AS number are equal. Okay, I need you, you need me. Okay, we are equal, and then we are doing peering. So usually there is a company here that builds the infrastructure, builds the buildings with the air conditions, with the data center, with backup powers, with interconnectivity, and then yeah, everyone can go there and then put their own things like their own routers, servers, and etc., and then they connect to each other. So that's how the IP peering looks like. And then here's the IP transit, like what I said. Yeah, so this is your ISP. Okay, and this is you. This is other customer with AS number, doesn't matter. So guys, so if you want to go to internet, you have to go through this ISP, right? So it means that, but I have AS number, yes, but your position is not equal. Why? Because you need this ISP to connect to the other AS number, correct? To go through the Google, yes. So that's why your position here, this is you, and then your ISP is not equal. You need them to go to the internet. So that's why we call IP transit. And then you have to pay for them. So that's the meaning of IP transit. Okay. So this is an example, yeah, of what happened in Indonesia. So is there any places for where we do peering? Yeah, there are many. In Bandung, they have Jabar IX in one of the building in the city. In Jakarta, they have two, more than one. They have IIX, they have OpenIXP. For example, this is IIX. Okay, this is OIXP. Okay, OpenIXP. Okay, in other buildings, they have other interconnectivity as well. Okay, so if you put your router here, and then you will do peering between provider A or provider B. Okay, so provider A and B, they can connect to each other. But how can you connect to the provider F here, for example? Look, all name provider here change to AS. AS, because in BGP, everything is AS. How can you connect to ASF? Why do I need to connect to ASF? Because provider ASF here is one ISP, and then they have customer, and then that customer needs to connect a server here. How can you connect? And then this ASF is not connected through IX here, so that's why you need the third-party AS. Okay, with that has connectivity between these two peering, and then it's called transit. Okay, so you have to pay if you want to connect from provider B and A. I mean AS A and B, you don't have to pay. Yes, you have to pay for just connectivity, because if you put a router and then you will consume electricity, and then electricity requires money. That's why you have to pay per month for renting a space in an IXP, Internet Exchange Point. Okay, but to connect to other providers, you need third party, and then that case is called transit. You have to pay money for them. So I have a question here from, who is it? Daddy. So it means that even though if we have an AS number, yeah, yeah, it doesn't matter if you have your AS number. You need to have help, support from other AS number to connect to the internet, right? So it doesn't mean that, okay, I apply for IP address block and then I already have AS number. So it means that I can connect to the internet automatically. How? No, it's not like that, man. Okay. Is it possible that you have AS number and then a public IP address, but you cannot connect? Yeah, that is possible. Yeah. Yeah, it means that your IP address, your public IP address, is used in your own place. Okay, guys. Oh, okay. So it's already 20:47 now, and I think it's time. There's no practice. Okay, it's already late here. Sorry, guys. And anything else? Oh, yeah. Thank you for the attention. Please submit your feedback here. And then we have our own Facebook page. Slide will be available on Slideshare, and recording will be available on YouTube. Okay, so I already put them. Oh, sorry. I put everyone in the meeting. Okay, so guys, please submit your feedback here. If you still have any questions, you can type something in the group chat. What are the advantages or disadvantages of my organization that his own AS number? Yeah, very good questions. Yeah. So in order to connect to the internet, I don't have to have my own IP address. Yes. And then what IP address do I use? Well, IP address that belongs to the ISP. So this is the ISP, and then the ISP has a blocks of IP address, and then they give you their own IP address. But what happens if you have your own IP address like this? And then you will have your own IP address. So your friend over here will connect through your IP address. So your IP address will be yours. So if you change your ISP, your IP address will be same. Can we make our own ISP? Yes, we have that webinar many months ago. Okay, guys, so I think that's all. Hopefully, this webinar has is an enlightenment for you guys. Okay. So, what is the benefit that we can connect to the international and do IP transit? Yeah, you can put your own router in the peering, but after that, how can you connect? Yeah. So, for example, you have your own IP address here. You connect through this. Okay, your ASX, for example, you connect through this. Okay, and then what else? It's just there. And then if for example this is Telcom wants to connect to your AS, how can you connect to the Telcom subscriber? You need to have other peering that connects to Telcom. Okay, so yeah, so that's how you connect to other AS. So peering, it depends on the peering. You need to have, because peering is only exchange the prefix between the peer. But there is other places for peering as well, where they have a potential customer. So this is for example, this is you as Amazon or Tokopedia. This is you, and then you just put your server here and the IXP, and then that Tokopedia can only be accessible for this customer, and then you are losing other customer over here. Okay, so hopefully that answered the questions. Another question, realize BGP established local IP is not reachable. It's too technical. I'm not talking about that here. So just contact our training. We'll have a BGP workshop in a few weeks. So just contact us. Yeah, so recursive is one skill. So as I said, BGP is when you use internal BGP, it will be combined with IGP like OSPF, and then they will do recursive looping for finding out the destination of the BGP peering, internal BGP peering. Okay, guys, so I think that's all. So it's time for, wow, a video. So please, this is a photo session. Please turn on your, please turn on your camera. Okay, say hi. Hey. Any questions? So are you feeling better with the BGP right now, or it makes you more confusing? So please say something in the group chat, and then hopefully this webinar can oops, yeah, this webinar can give some benefit for you guys. Okay, I will stop share. Okay, and then set the view gallery. Okay, please again put something in the feedback. Okay, please feedback. Okay, feedback is very important for us. Okay, I put again the URL for feedback, put here for everyone. Okay, please submit your feedback, and then okay, let's go for a photo session. So previously it was 70. Wow, now it's 54. Doesn't matter. Okay, thumbs up. 1, 2, 3. Yeah. Woohoo. Yeah, next page. 1, 2, 3. Yeah. Wow, another page. Okay, let's take another picture. 1, 2, 3. Great. Okay, guys, that's all. Thank you very much. Yeah, I think that's all. So hopefully this webinar can bring an enlightenment for you. So in case, because I can see many questions related to BGP, they are still confusing about what is IP transit. Actually, it's a very easy concept. You know, transit means you have to pay because you don't have any options to go to the internet. So that's why you need somebody that can offer you a connection to the internet. Okay, please again submit feedback. Okay, I'll post it again. Please submit feedback, and then if you have any topics, and then you can write the topics in the feedback. Okay, guys. Again, thank you very much for coming. Hopefully you enjoyed the webinar. Thank you very much, and then I will see you in the next webinar next week. Again, thank you very much, and then have a nice day. Keep safe, and then yeah, God bless us all. Thank you.
Thank you.
Thank you, everybody.